Hello guys, this is going to be a video about the study packet and some questions that you guys might have. So I'm gonna answer those in here. And I expect you guys to complete any revisions that I give you before the last week. So they're all going to be due Wednesday of week 5. Okay, so right now the deadline for the second checkpoint is up, so it closed at 5, so you cannot submit anything else. So if you submit something in there and I consider it is a substantial work, then I'll give you a partial credit right now. And when you submit all of these corrections that I'm going to put on here in this video, then I'll give you the full grade. Okay, so I'm not gonna do questions, excuse me, 1 and 2, since those are definitions. You guys have to be able to look those up in resources. Okay, so I'm going to start with question 3, which says, what is the concentration in micrograms per ml? So these are the units of concentration that we're looking for. If I dissolve 5 grams of sodium chloride in 1.2 liters of water. So what we have to do in this case is convert those 2 units to the desired concentration units. So we have to convert those 5 grams into micrograms, and then we have to convert this 1.2 liters into milliliters. So let's go ahead and start doing that. So 5 grams, I'm going to do dimensional analysis. Okay, so I have to find a conversion factor between grams and micrograms. So if you look up the conversion factor between grams and micrograms, you're going to see that 1 gram has 1 million micrograms. So this is the conversion factor. Grams and grams are going to cancel out. Where did I get this factor from? Excuse me, you can get it from the internet. And on Chemistry 1, there's a PowerPoint. If you save the PowerPoints, that has a chart that has all of these conversion factors between, the units and decimeters, centimeters, millimeters, kilometers, megameters, micrometers, all of these prefixes. Okay, so you do this multiplication first, and you're going to get 5 million micrograms, which is the same as 5 times 10 to the power of 6 micrograms. So that's the first number that you need, because the units they need to be micrograms per ml, right? So that's the first conversion. The second conversion is going to be the 1.2 liters, and we are converting to milliliters. And I know 1 liter has 1,000 milliliters. So liters and liters are going to cancel out. And if you do this multiplication, you're going to get 1,200 milliliters. So now that you have these two numbers, if you want them to be micrograms per ml, then you have to do a division in this case. So 5 million divided by 1,200. Then you do this on the calculator and you should get the answer. Okay. So 5 million micrograms divided by 1,200 mLs. And the answer should be, let me put it in the calculator really quick. The answer should be 4,166.67 micrograms per ml. So this should be the first answer. This is how we're going to solve the first, well, not the first problem, but problem number 3. Okay, and then there's a typo on the PDF. So there's 2 problems number 3. Okay, the second problem number 3, it's asking for a formula that's needed to make a dilutions from a stock solution. This formula comes in the PowerPoints, right? It's going to be molarity 1, volume 1 equals molarity 2 times volume 2 of the dilution. You can also find this as C1B1 equals C2B2. Okay, this is the same formula. This is the concentration. As long as those 2 units are the same, as long as these 2 units are the same, right? It can be liters or it can be both milliliters. That's going to be fine. So you just plug it in there and then solve for the variable. So number 4, you guys have to look that up. Number 5 says determine the amount of NaCl needed to make 30 mLs of isoosmotic IV solution. So first of all, you have to look up what the concentration of an isoosmotic IV solution is. This isoosmotic solution is going to be a saline solution, so it's going to be sodium chloride at a certain concentration, so that it has the same osmotic pressure as the blood in our veins. This is because if you have a different osmotic pressure on the solution that you inject in an IV, then you can start damaging the red blood cells. They can either burst or they can swell, and all of this is harmful for the red blood cells. Okay, so we have to find what an isoosmotic solution is. And if you look it up in the internet and you have to find a reference for this, right, you're going to find that the concentration of an isoosmotic solution is 0.9% of sodium chloride, which is the same thing as 0.9 grams of sodium chloride per every 100 mLs of water. So this is the isoosmotic IV solution, the concentration of an isoosmotic IV solution. So we have to prepare 30 mLs. Okay, how much sodium chloride do I have to have? Okay, so the way that you can do this is going to be a proportion, right? So the first proportion or the first ratio is going to be 0.9 grams of sodium chloride per every 100 mLs. This is the isoosmotic solution. And if you want to make 30 mLs of this isoosmotic solution, how many grams of sodium chloride you're going to need? Okay, so this is a proportion. There's two fractions in there. You just have to multiply the numbers across and then divide by the leftover number. So you multiply these two numbers over here, 0.9 grams of NaCl times 30 ml. So you multiply diagonal, and then you have to divide by the leftover number, which is 100. So you divide by 100 ml of water, and the same mLs of water cancel out, so the result is going to be grams. This is how many grams you're going to need to make your isoosmotic IV solution. Okay, so I'm just going to put those in the calculator. 0.9 times 30 divided by 100. So the total amount of grams that you need is going to be 0.27 grams of sodium chloride. Okay, so this is question number 5. Now, question number 6 says, starting with a 1 ml of 10% NaCl in water, how much water do you have to add so that it becomes isoosmotic, right? So that it becomes isoosmotic. So the pressure, the concentration of an isoosmotic, again, 0.9%. Okay, sodium chloride in water. So since we're making a dilution, you can use the M1B1 equals M2B2 formula. Since we're not using molarities, I'm just going to call it C1B1 equals C2B2. But this is the same formula. Okay, so C1B1, those are the starting concentration and starting volume. These variables over here. And this is the desired concentration and the desired volume. So because of this problem, it says the initial concentration, it's asking for 10%, right? 10% of the initial concentration, and the initial volume is 1 ml. So this comes from the problem. This is initial. How much water do I have to add so it becomes an isoosmotic solution? This means that the concentration, the desired concentration, has to be isoosmotic, 0.9%. And I am looking for how many mLs this solution has to have. Now, let's go ahead and calculate this number. So the only thing that I have to do in order to solve for x is going to divide by 0.9% both sides, 0.9% both sides. Percentages cancel out. And I'm just going to do this on the calculator again, 10 times 1. 10 times 1 divided by 0.9. And the result is going to be 11.11 mLs. That's going to be my result. This has to be the volume of the solution, 11.11 mLs. But since in this case, you already have 1 ml, you're making a dilution, right? You take 1 ml of this concentrated solution and you want this to be 11.11 mLs, then you have to do a subtraction, right? So I'm going to subtract the 1 ml that I already have in the solution, and the result is going to be 10.11 mLs. So think about it this way, right? So you have already 1 ml of solution. That's 1 ml of solution. If you add 10.11 mLs, then the final volume is going to be 11.11 mLs, and we know that 11.11 mLs is going to have 0.9% of the solution, of concentration of the solution, which is isoosmotic. So the final result should be 10.11 11 for this problem. The next problem, the last problem, make sure that you have all of these corrections and correct calculations by the next deadline. Okay. So next question says, I'm going to change coloring here, starting with 15 molar of NaCl as a concentration, how much of the stock solution, this is the stock solution, right? Stock solution. Do I have to graph if I want to convert this into 500 mLs of a concentration of 1 molar? So the same, we're going to use the same formula, which is, I'm just going to call it M1B1 equals M2B2, since we have concentrations in this case. Okay, so M1B1, those are the starting concentrations, or the stock solution and the volume of the stock solution. So I know my stock solution concentration is going to be 15 molar, and the question is asking how much of the stock solution. So what's the volume of the stock solution that I have to take so that I can make a new solution? So we are looking for this volume one. I don't know the starting volume. How much of this do I have to take in order to make my dilution? That is going to have a molarity of a final concentration or a desired concentration of 1 molar, and it has to be 500 milliliters. So again, at this time we're solving for volume 1. This is volume 1. So we're going to divide by 15 molar the left side and 15 molar the right side. Okay, so this 15 molars cancel out, and the desired volume, which is B1, is going to be equal to, and then you put that again on the calculator, right? So 500 times 1 divided by 15, and the resulting volume is going to be 33.33 mLs. So what this means is that if you take 33.33 mLs of this concentration, 15 molar, and then you dilute it, you keep adding water until the volume becomes 500 mLs, then your concentration of that solution is going to be 1 molar. Okay, make sure that you include all of these corrections, and of course the other questions you have to look up the answers in the different resources, right? You can use the book, you can use books from other classes, you can use any material that any other professors gives you, but make sure that you are doing APA style in the citations, okay? APA style of a citation.